Okay, so now we have the aluminum beam prepped, and now we're going to focus on our work surface that we're going to use to position the strain gauges. We're going to clean that off, and let me show you the gauges. So I've got two of them, and at first glance it's very difficult to tell the difference between these gauges. This first one, this is a traditional CEA series gauge. This one happens to be a CEA 13250UW120, and we've been building CEA strain gauges since the early 1980s. And the reason they're so popular is that they have a protective film over the grid of the strain gauge, and they also have larger copper-coated tabs to make lead wire attachment much easier. If we look at the details for this CEA series gauge, you'll see that it has a resistance of 120 ohms plus or minus 0.3%. The gauge factor is 2.120 plus or minus 0.5%. Transverse sensitivity is 1.2 plus or minus 0.2%. And this is the coefficients for the thermal output for this gauge. So we test them, since they're a 13 compensated gauge, we test them on 2024 T4 aluminum, and we establish what the gauge generates as a function of a temperature change when the aluminum is allowed to freely expand and contract, and we give you that data. So you can take that and plug it into your data acquisition, or you can plug it into a spreadsheet and plot it. The gauges are from that foil lot. This work order information helps us track it where it goes through production. If you wanted to order more of these, you could either use the gauge designation down here at the bottom, or you could use the item code. Either way, our customer service department can determine what you're looking for. In a pack of these gauges, there's 5 pieces, and that's a date code of when they were manufactured. And all of this information is contained on this 2D barcode. So if you have a barcode reader or scanner, you could shoot that and automatically pull in this data into your data acquisition system or into your logging system. The second strain gauge is this one, and if you look at it, it really looks identical. It's also encapsulated. It's made out of a cast polyimide backing, just like a traditional CEA series gauge. It's got a film overlay over the grid to help to protect it from me and you while we're trying to install it. It's got large copper-coated tabs, identical in size to the other gauge. So really, this gauge is a drop-in replacement. Now in this particular case, this one is a 350 ohm resistance, where the one that we've been using for many years is a 120. So that's one of the changes that we're going to make coming up in our workshops, is to switch over to a 350 ohm strain gauge. If we look at the data sheet that's provided with it, you'll notice much of the same information, and really this should be a drop-in replacement. We've got the resistance, temperature coefficient, gauge factor, transverse sensitivity, all the coefficients, as well as the foil lot, and then the item code, and then the part number. And when you look at this strain gauge, the only difference you'll see in the gauge designation is an A that we add after the W. This is a CEA 13250UW. This particular one's 350, and we're going to switch over to the higher resistance gauges because we find that, quite frankly, more of our customers use 350 ohm strain gauges these days than they do 120s. So with that being said, let's do a little bit of house cleaning. So one of the first things I'm going to do is take the neutralizer, and I'll just take a few drops of it, put it on the piece of glass like that, and I'll take a gauze pad, and I'm just going to fold it and clean off this surface, because this is the surface we're going to use to prepare and position the strain gauge. And the other thing I'm going to do is take my tweezers, the ones that I'm going to use to handle the gauges, and I'm just going to kind of clean those off. Just clean off the tips of them using a gauze pad and some neutralizer. And then the basic idea is that we're going to take these two gauges, I'm going to try to lay them out one at a time on the piece of glass, put a piece of handling tape over top of it, and I may have to trim it because I've got a limited amount of space where these gauges are going to be installed, and I want to have them both as close as I can get them to the middle of the beam and positioned at the same spot, because the idea, of course, is to compare the response of these two different strain gauges. So the first thing I'm going to do is take the traditional gauge. I'll open up the folder, grab it by the corner. There you can see the bonding side, there you can see the top side. Just like with any other strain gauge, you want to lay it with the shiny side up and the dull side goes down. That's very important. Now, in order to be able to position this gauge onto the aluminum beam, I need to put some tape on it. So what I'm going to use is this, this happens to be PCT2M. Now we've updated to PCT3M, but it's really the same product, it's just a different roll size. What I'm going to do is tear off the first few inches and throw that away because it could have picked up some dust. And then I'll take a piece of tape that's about, roughly speaking, about 4 to 5 inches long. And what I'm going to try to do is I'm going to go ahead and say that this gauge is going to be on the left side. So I'm going to try to capture it so that I get it right over top of it and have it biased. I don't know how well you can see that, but I've got the tape biased right along the edge, and what that's going to allow me to do is now position this other gauge right up near that edge. So I'm going to take that, move it here. I'll take the second strain gauge, and you can go ahead, you could either do these one at a time or you can position them both. Either way is fine. I'm going to go ahead and position both of them out on the piece of glass about the way they're going to be installed onto the surface of the beam. I have a bigger gap on the glass than I will once I transfer it over. So once that one's in place, I'm going to push these folders to the side. Take another piece of the gauge installation tape, again about 4 to 5 inches long. Take that, move it out of the way. And the same thing here. I'm going to try to take this and bias it so that now I've got both gauges captured in the tape, and you can see now I've got very little tape that's going to be in between them, so I can take these two and I can position them close to each other once I transfer it over to the surface. Another thing that I like to do is take the tape and just kind of fold the end of it back over like that. It gives you a little bit of a handle. It makes it a little bit easier to pick the tape up off of the glass. And we're going to orient these strain gauges so that the tabs of the gauges are pointed down toward what will be the load into the beam. And I'll go ahead and start with gauge 1. And what I'm planning to do is I'll get both gauges transferred over. I'll put one more piece of tape over top of everything, and then I'll lift it back, apply the adhesive, and then push it down into place. So I'll just start with the traditional CEA series gauge. I'm going to lift the tape, and as you do this, make sure you lift the tape at a shallow angle. Don't pick it straight up, lift it at a shallow angle. Once you get past the gauge, then you can go ahead and lift it on up. I'll pick it up, and I'm going to transfer it. Over there to the beam like that. Again, I've tried to split it so it's in about halfway. And then we'll do the exact same thing with this second gauge. I'm going to lift the tape again at a shallow angle. And once you get past the gauge, then you can go ahead and pick it on up off the piece of glass. And we're going to position it so that we've got that gauge on there as well. So now I've got both of them installed. They are both right along that burnished alignment mark. As I'm looking at it, one of the things, I've got a little bit more space down here at the bottom than I do at the top. So what I think I'm going to do is scooch them over ever so slightly. Scooch being a technical term. I'll just pick it up again And I'll move it a little bit closer to that side. It'll just give the other one just a little bit more room. And again, as long as you use the same technique, you can lift the gauge up and move it around. And then put it right back down. Once I'm happy with it, pretty even now. As you can see, the two gauges side by side. Again, the load will be down here. I'm going to run one more piece of tape over the top of them, and then we're ready to start applying the catalyst and apply the adhesive. So in order to cover that gap, again, I'll take another piece of tape, about 4 to 5 inches long. Lay it right over the top, like that. Fold the end of it over, and now it's effectively like I've got one relatively wide piece of tape. Now what I'm going to do is just like any other time, I'm going to find my adhesive. I've got the M-Bond 200. As you know, it comes with two components. It's got the M-Bond 200 catalyst we put on first, and then the M-Bond 200 adhesive. This catalyst serves as a control. When you're in very dry climates, it can take longer for cyanoacrylates to cure, so this helps to speed it up a little bit. And when it's very wet, it actually can kick over quicker, and this will help to sort of slow it down. So it just basically helps to make sure that this cyanoacrylate will cure. And unlike some manufacturers, we apply the catalyst only on the backing of the strain gauge. And less is more. The less catalyst you use, the better. So let me show you how we'll do that. First thing I'm going to do is just take the tape and I'm going to lift it, pick it up at a shallow angle, and I'll pull it back about an extra 1/2 inch. It's a little bit thicker than normal, so it's kind of wanting to fold back over. But I'll actually, let me show you another little trick. I'll just take it and kind of fold it back like that. And take the catalyst, shake it a few seconds, and then as you take the cap, instead of just going directly to apply it, you're going to put it on way too heavy. So what we ask you to do is take it and touch the inside part of the bottle, somewhere in the neighborhood of 10 to 12 times. What you're trying to do is put the vast majority of the catalyst right back in the bottle. And the reason for that is the catalyst is 98% isopropyl alcohol. It's the 2% that we need. Most of this is alcohol. Just take it and lay it flat and use a single wipe across the gauges like that. And then you need to wait 60 seconds. So I'll look at my watch. I'm at 24. So now we wait a minute. Now while we're waiting, one of the things I like to do too is to go ahead and get your gauze pad ready, because we're going to use this gauze pad as a squeegee. So I'll just take it and fold it, and then fold it in half again like that. Have it ready. We've got the M-Bond 200 adhesive. You should always check the date of it. In this particular case, the expiration date is December 2019, so we know it's good. If it's a brand new bottle of M-Bond 200, if it has, and it usually does have some liquid in the nozzle, what I like to do is squeeze that out. So I'll squeeze a few drops out of it just to make sure that I'm getting fresh adhesive from the main bottle. And this is where you can't shortcut it. What we find over the years is that most people that make a mistake with M-Bond 200, it's due to the catalyst. They end up putting it on way too heavy, and they don't wait long enough. So you got to make sure if you put it on in a real thin film like I did, 1 minute should be fine. If you put it on and you can tell it's blue, you probably put it on a little too heavy, and you need to wait maybe 3 to 5 minutes. All right, so once we've gone past our 1 minute. So what I'm going to do, since I've got two gauges, I'm going to go ahead and put maybe 2 good drops of adhesive right there at the junction of the tape. Probably 1 would be fine. And you need to move quickly here. So have your gauze pad, take your tape, pull it over, hold it at an angle, and then just push the adhesive underneath the strain gauges all the way out to the end. As soon as you do that, take your thumb and put your thumb over top of it, and you want to keep it on there for a full 60 seconds. So again, checking the watch, I'm at 20. So I'm going to wait a full 60 seconds for this adhesive to cure.